Hello everybody. In this video I will teach you how to factorize quadratic expressions, even cubic expressions. Before we start, I need you to understand that we have four types of questions for factoring. This is the first one, the difference of two squares. Squares, for example, like 36 is a square number because 36 we can write as 6 times 6. So 36 we can express it as a product of the same factor twice. That's why it's square number. For a different example, for square number we have 49, 7 squared, 64, 8 squared, 81, 9 squared. So we have infinite number of square numbers. Also for expressions we have a perfect square expression like x squared is x times x. To factorize this we need two brackets. This x squared will be x and x. This 25 is positive 5 and negative 5. You can put negative or positive with any order. So factoring, it means divide this as a product of two factors. Difference of two squares, a different example. X squared is x times x, 36 is 6 and 6. You can write negative or positive with any order. For this example, we can write a, b times b plus 9s. In this example, we can rewrite this as 1 times 1, 16 is 4 times 4, y squared is y times y, 1 positive, 1 negative. So if any time you want to expand these two brackets, you will have this answer. Here we have a different example of factoring difference of two squares. We have two squares, two brackets. 81 is 9 times 9. X squared is x times x. 49 is 7 times 7. One was positive, one with negative. You can write negative 7, positive 7 with any order. Can you find the product or the factoring form of this one? This x power 4, we can rewrite it as x power 2, 16 is 4 times 4. One was positive, one with negative. You can see that we have sum of two squares we cannot factorize. X squared plus 4. When it's negative or its difference, we can factorize the difference of two squares to get two brackets, x and x, 2 and 2, positive and negative. But this is not, this is unfactorable, so we cannot factorize this. We leave it as it is. This is the final answer, a product of three factors. This one, you may need to find difference of two squares, but this is not square number, this is not square number. You can take this 2 from both of them, so you can divide this by 2 and rewrite what's inside the bracket to be x squared minus 25. This 2 will be outside, and you know the answer for this. X minus 5, x plus 5. So this is how to factorize difference of two squares. When it comes to cubes, we have difference and sum of two cubes. Cube numbers like 1, because 1 times 1 times 1 is 1. 8, because this is 1 power 3, this is 2 power 3. 27, this is 3 power 3, and so on. We can find 64, 4 power 3. Also in square numbers, 64 is 8 power 2. So 64 is one of the square and cube numbers. 1 is a common number between square and cube numbers. How to factorize this sum or difference of two cubes? You can see here I put the same numbers, same expression, but with a different sign to show you that we can factorize difference or sum only for two cubes. We will have two brackets, one for two things and one for three things. In the first bracket, the small one, we write the root of everything. So the cubic root of x power 3 is x. This is how to get x power 3. The cubic root of 8, which is 2, because 2 times itself 3 times, this will give us 8. Then we put this sign of the question. To find what's in the second bracket, multiply this by itself or make it square. This would be x squared. This by itself, it would be 4. Multiply them together, they will give us 2x. We put them in the middle. If the example is positive, plus, we put this plus, but we change this to be minus. But the last one is always positive. To understand more, in the next one, two brackets, the root of x power 3 is x, the root of 8 is 2, this is minus, we put it minus. Multiply this by itself, it's x squared, multiply this by itself, it's 4, as we did above, then multiply them together to give us negative 2x. We put it, but we change the sign to be positive. So the last one is always positive, and this one is like this, the question, but this one is opposite for the first one. So if it's positive, put this negative. This is always positive. If it's negative, put this positive, and it's always positive. Here we have 27, which is 3 power 3, 64, which is 4 power 3. So we have in the first bracket 3x plus 4, the cubic root of everything. In the second bracket, 3x times itself, it's 9x squared. 4 times itself, it's positive 16. Multiply them together, it will be 12x. Put it negative 12x. So this is one is positive, this one is positive like the question, but this is opposite of this to be negative. So this is the video. This is the video for difference or sum of two cubes and difference of two squares.